For 700 years, the Black Death had no origin. Historians knew roughly when it arrived in Europe, the autumn of 1347, 12 ships docking at Messina, sailors already dying on the decks. They knew where it went from there, westward, through Sicily, and up the Italian peninsula, into France, into England, into Germany, a wave of death, moving at the speed of medieval trade routes, killing somewhere between a third and half of everyone it touched. But where it came from, before Messina, before the ships, before the Black Sea ports, was always a matter of inference. Documents mention plague in the east. Accounts from the 1340s described massive die-offs along Mongol trade routes, but no one could say exactly where, or when, or how. For 7 centuries, the origin of the deadliest pandemic in recorded history was a gap in the record. In 2022, researchers published the answer, not as a theory, not as an inference, as genomic data extracted from the teeth of people who died in 1338, 9 years before the plague reached Europe, in a pair of cemeteries on the shores of a mountain lake in Kyrgyzstan. The graveyard had named it. The study was led by a team, including Maria Spiro, Philip Slavin, and Johannes Kraus. What they found was not circumstantial. The ancient Y. pestis genomes recovered from those burials sat at the base of the phylogenetic tree for the entire Black Death lineage. Every European strain ever sequenced, from London, from Paris, from Hamburg, descended from what was in those graves. The Black Death did not arrive in Europe from the East, in some vague general sense. It arrived from a specific place in a specific year, and the DNA proved it. The 2 cemeteries are called Kyrgyzstan and Barana. They sit in the Chui Valley, near the northern shore of Lake Issyk Kul, an alpine lake in the Tian Shan Mountains of modern Kyrgyzstan, 1,600 meters above sea level, surrounded by snow-capped peaks. In the 14th century, this region sat on a branch of the Silk Road. Merchants and traders passed through. Communities of Nestorian Christians and Central Asian traders had settled there. The cemeteries had been known to researchers since the 1880s, when Russian archaeologists documented an unusual cluster of medieval tombstones. The stones bore inscriptions in Syriac, the liturgical language of Nestorian Christianity. Several of them recorded not just the name of the person buried, but the cause of death. The Syriac word used was a term for pestilence, and the dates on those stones were concentrated in a narrow window, 1338 and 1339. Philip Slavin, a historian at the University of Glasgow, had been studying the Kyrgyzstan cemeteries for years before the 2022 study. His 2019 analysis argued the inscriptions were consistent with a plague outbreak, but he could not prove it without molecular evidence. The 2022 paper was the confirmation. The study was published in Nature in September 2022. The title named the location directly, Lake Issyk Kul, 1338. It answered a question that had been open for 7 centuries. The study was led by Maria Spiro, Philip Slavin, and Johannes Kraus at the Max Planck Institute for Evolutionary Anthropology in Leipzig to extract usable, ancient DNA from 700-year-old teeth. The team worked in one of the most tightly controlled research environments in science. Every surface decontaminated before samples were introduced. Researchers in clean rooms with filtered air and full protective equipment. The protocols were designed to eliminate any possibility of contamination. From modern Yersinia pestis, which still circulates in Central Asian rodents today, of the 7 individuals sampled, 3 yielded Yersinia pestis DNA of sufficient quality. 2 of those 3 came from the Kyrgyzstan cemetery. The genomes were incomplete, ancient DNA fragments over 7 centuries, but complete enough to place on the tree. The phylogenetic tree of Yersinia pestis is one of the most studied in science. Researchers have sequenced hundreds of ancient strains from victims across 5 continents, from the Bronze Age through to the 19th century. Third pandemic. When the Kyrgyzstan genomes were placed on that tree, their position was unambiguous. They sat at the base of branch 1, the branch that produced the Black Death, not on a side branch, not on a dead end, at the root of the main pandemic lineage, in the exact position a genuine origin strain would occupy. The diversity of the Kyrgyzstan samples was itself significant. 2 strains from the same small region, showing slight genomic differences. This indicated that Yersinia pestis had been circulating in this area long enough to accumulate variation. This was not a single spillover event. This was an established local reservoir producing the strain that became the Black Death. The molecular clock analysis placed the origin of the Black Death branch between 1268 and 1343. The Kyrgyzstan burials dated to 1338 and 1339 fall squarely inside that window. The genomic evidence and the historical record pointed at the same time and place. The researchers addressed another objection immediately. If the origin was in Kyrgyzstan, why had no one found it before? The answer was methodology. The tombstones had been photographed in the 19th century. The graves had been opened. The bones were documented, but the technology to sequence bacterial DNA from ancient teeth did not exist until the 2010. The evidence was in the ground the entire time. The field had to wait for the tools. The genomes also allowed researchers to address the China question. Some chronicles described massive die-offs in China and the Mongol Empire in the 1340s. Some historians had pointed to these as evidence of a Chinese origin. The phylogenetic position of the Kyrgyzstan strains effectively closes that debate. If the Black Death had originated in China, those strains would appear at the base of the tree, and Kyrgyzstan would branch from them. Instead, the Kyrgyzstan strains are at the very base. There is no upstream ancestor. The origin was here. Ancient genomes are sequenced in fragments, short reads of genetic material extracted from preserved tissue, usually from the dense bone of teeth or the cochlea of the inner ear, where DNA survives longest. Those fragments are aligned against a reference genome, then compared against every other sequenced Y. pestis genome, using statistical methods that calculate genetic distance, how many mutations separate one genome from another. Those distances, combined with the known mutation rate of the bacterium and the radiocarbon dates of the burial, place the genome in time as well as genetic space. Here is what the Kyrgyzstan finding changes and what it does not. What it confirms: the Black Death originated not in China, not in the Mongol heartland, not at the Black Sea. It originated in the Tian Shan Mountain region of Central Asia, in a community along the Silk Road in the late 1330s. This has been debated for more than a century. The DNA resolves the debate, but the 2022 finding is not just about location. It is about what the DNA itself reveals about the nature of the outbreak. A geographic identification from historical records can always be argued. A phylogenetic position on a global bacterial family tree cannot. What it complicates: the popular account of how the plague moved west. The standard narrative held that the Black Death originated somewhere in Central or East Asia, was carried westward by Mongol armies and traders along the Silk Road, reached the Crimean port of Kaffa on the Black Sea by 1346, and from there spread into Europe by ship. The 2022 study does not invalidate this route, but it anchors the starting point at a specific location that was not previously identified. What it raises: the question of the animal reservoir. Yersinia pestis does not live in humans between pandemics. It lives in rodents, marmots, gerbils, ground squirrels that act as long-term carriers, maintaining the bacterium across generations. The Tian Shan Mountains are still today one of the primary Y. pestis reservoir zones. The long-tailed marmot, Marmota cattata, is endemic to the region and a known carrier. The 2022 study identified that the Kyrgyzstan population had been exposed to a strain that had recently diverged from its rodent reservoir, acquiring genomic characteristics associated with human-to-human transmission. The specific ecological event that caused the spillover is not visible in the genomic data. What is visible is the result. The Silk Road in the 14th century was not a single route. It was a network of overland and maritime connections spanning the Eurasian continent, linking China to the Mediterranean through dozens of relay cities. The Chui Valley, where the cemeteries sat, was not a backwater. It was an active node, a place where traders stopped, goods changed hands, and populations from different parts of the network interacted. This is precisely the kind of location where a pathogen making the jump from rodents to humans would find its first human amplification event: high human contact, high rodent proximity, high movement of people onward. Case Study 1. The Siege of Kaffa, 1346. The most documented single event in the early spread of the Black Death is the Mongol siege of Kaffa, a Genoese trading colony on the Crimean coast. In 1346, a Mongol force under the Golden Horde besieged the city, according to a contemporary account by the Genoese notary Gabriel de Mussis. When plague broke out in the besieging army, the Mongols catapulted the bodies of the dead over the city walls. The Genoese merchants inside then fled by ship, carrying the infection to Messina and other Mediterranean ports. The catapult story is disputed. De Mussis was not an eyewitness and wrote after the fact, but the core event is not disputed. The Mongol army was struck by plague in 1346. The Genoese were exposed. Ships leaving Kaffa in late 1346 and early 1347 carried plague to the Mediterranean. What the Kyrgyzstan data adds is the upstream portion of the story, the strain that the Mongol army carried to Kaffa. The strain that reached Messina in 1347 was genetically continuous, with the strains circulating in the Chuai Valley in 1338 and 1339. The phylogenetic evidence indicates the Black Death lineage was moving westward for roughly a decade before it reached Europe. The Kyrgyzstan outbreak was the spark. Kaffa was the delivery mechanism. No ancient Y. Pestis DNA has yet been recovered from Kaffa itself. The claim of continuity is phylogenetic. The strains appearing in Europe in 1347 are genetically consistent with descent from the Kyrgyzstan route. The specific relay stations along the way, which Silk Road communities carried plague through Transoxiana, Persia, the Caucasus, are not yet documented. Each of those communities may have its own graves, its own teeth, its own ancient DNA, waiting to be extracted. The story of the Black Death's westward journey is not fully told. Case Study 2. The East Smithfield genomes, the most thoroughly sequenced ancient plague genomes from the Black Death period, come from the East Smithfield burial ground in London, an emergency cemetery established in 1348 when plague arrived in England. The East Smithfield genomes have been in the ancient plague literature since 2011, when placed on the same phylogenetic tree as the Kyrgyzstan genomes. The relationship is clear. The London strains are descendants. They sit further out on branch 1, having accumulated additional mutations during years of westward travel and European spread. The Kyrgyzstan strains are their ancestors, older, more basal, carrying the genomic signature of the lineage. Before it began its rapid diversification during the pandemic, the genomic distance between the Kyrgyzstan strains and East Smithfield corresponds to roughly 8 to 10 years of evolution, consistent with the historical timeline. Origin in Kyrgyzstan 1338, westward travel through 1346, arrival in London 1348. Case Study 3. The diversity question. One of the most significant findings in the 2022 study was not just the position of the Kyrgyzstan strains on the tree, but the diversity among them. The two sequenced strains from Kyrgyzstan and Barana are not identical. They show small but measurable genomic differences, distinct positions on the phylogenetic tree, both basal to branch 1, but not the same strain. A single spillover event produces a single founding strain. Multiple distinct strains in the same small area at the same time indicates the Y. Pestis population was diverse and established. The rodent reservoir had been maintaining the bacterium long enough to produce variation. The researchers described this as evidence of a big bang diversification event, the point at which the Black Death lineage expanded rapidly from a diverse local reservoir into the pandemic strain that swept the world. The Chuai Valley in 1338 was not just the first place the plague struck. It was the evolutionary cradle of the entire pandemic. The Big Bang metaphor used by the researchers has a specific genomic meaning and triggered the founding of multiple human-adapted lineages simultaneously. In evolutionary biology, a rapid radiation from a single ancestral population produces a burst of diversity, many lineages diverging in a short period. That is what the Kyrgyzstan data shows. Multiple branch, one lineages appearing simultaneously at the base of the tree, all rooted in the Chuai Valley, all dated to the same narrow window. The implication is that the rodent reservoir in the Tian Shan Mountains experienced a population event in the late 1330s, a boom, a range expansion, and environmental stress that drove contact with humans. For 700 years, The Black Death had an incomplete address. Now, it has a full one. The outbreak that killed between 75 million and 200 million people. That ended the medieval demographic order. That dismantled feudal labor systems and restructured European economies. That outbreak began in the cemeteries of Kyrgyzstan and Barana, along the shores of Lake Issyk-Kul, in the mountains of what is now Kyrgyzstan. In 1338, the DNA from the teeth of 7 people buried there is the earliest confirmed genomic evidence of the Black Death lineage anywhere on Earth. Every European plague victim ever sequenced carries a strain descended from what those 7 people carried. The chain of ancestry runs directly from the Chui Valley to London, to Paris, to Hamburg, to every mass grave across a continent. This is what ancient DNA does when it works. Not inference, not probability. A direct answer to a question that 7 centuries of historical analysis could not resolve. The 2022 study also resolved a long-standing methodological question: whether ancient DNA from 14th century Central Asian graves could be recovered with sufficient quality to make phylogenetic claims. The Kyrgyzstan samples had been collected decades earlier during excavations, stored under conditions not designed for ancient DNA preservation. The successful extraction demonstrated that even imperfectly preserved ancient material can yield answers if the methods are sensitive enough. This expands the potential universe of ancient plague research considerably. Graves excavated a century ago, before ancient DNA was even a concept, may still hold recoverable material. The archive may be larger than the field has assumed. The cemeteries were excavated in the 19th century. The tombstones were photographed and documented. The anomalous death spike in 1338 was flagged and debated and left unresolved because no one had the technology to look inside the teeth. When that technology arrived, and when researchers collected the right samples, the answer was there. It had been there all along. There is a kind of justice in how the answer emerged. The 19th century Russian archaeologists who photographed the tombstones could not have known they were standing at the origin of the Black Death. Philip Slavin, who spent years arguing the historical case for the Kyrgyzstan origin, could point to the inscriptions but could not prove the pathogen. The ancient DNA team had the technology but needed the right samples. The answer required all 3: the archaeologists, the historian, the genomicists. None of them alone could have resolved it. Together, across more than a century of work, they did. Yersinia pestis is still in the Tian Shan Mountains. The rodent reservoir that produced the Black Death lineage in the 14th century did not disappear when the pandemic ended. The long-tailed marmot, the great gerbil, the ground squirrel populations of Central Asia continue to carry Y. pestis today. Researchers monitoring modern plague ecology have mapped active reservoir zones across the same mountain ranges where the 2022 study located the Black Death's origin. Between 1 and 17 human plague cases are recorded in the United States every year, all from a secondary reservoir established in American rodents after the 3rd pandemic. In Central Asia, the original reservoir has never gone away. Kazakhstan, Kyrgyzstan, and surrounding states report small clusters of human plague periodically, all traced to contact with rodent populations in the reservoir zones. The numbers are small, usually fewer than 10 cases per year in Central Asia, but they are consistent year after year because the reservoir is stable. And the conditions that allowed the bacterium to jump from marmots to humans in 1338, dense human populations, active hunting, trade route, contact, are not confined to the medieval period. They recur wherever humans move into or alongside active reservoir zones. The Black Death phylogenetic lineage, branch 1, eventually burned out in humans. The 2nd pandemic ended by the 18th century, but other branches of Y. pestis, including strains currently circulating in Central Asian rodents, are genomically close. The reservoir that produced one catastrophe is still operating. The 2022 study identified what happened in 1338. It cannot predict what will happen next. What it established, beyond the origin of the Black Death, is that the Tian Shan Mountains are a long-term evolutionary laboratory for Yersinia pestis. Strains have been diversifying there for at least 700 years of documented history, and likely far longer, before the written record begins. The graves at Kyrgyzstan held the answer to one question. The reservoir above the lake is still writing the next chapter.